Hi children, welcome to your home school. This is your next session of your class 9 mathematics NCERT or CBSE syllabus. Last session we have done about the introduction for exercise 1.5 children. So what we are going to do and what are all the topics will be there, we have covered in our last session, but in that session one more part of introduction is pending. So due to the lack of time, so I did not complete in that session, right? So in this session we are going to complete one of the basics, that is how to rationalize the denominator, and then we are going to complete some of the mains in your exercise 1.5. Okay children, let's start your exercise here. First main, classify the following into either rational or irrational. So you have here 5 sub-questions. So seeing that, you have to decide whether it is a rational number or an irrational number. So observe here, first one, what do you have? So 2 minus root 5. Do you remember one statement what I have said in before session? The difference of a, minus means difference, no? Difference of a rational number and an irrational number is always irrational. Okay, so you cannot do anything further here. So difference of a rational number and an irrational number is always irrational. So what you need to write here? You need to write here irrational. Either it is rational or irrational, you need to classify. Therefore it is an irrational. See the second one here, 3 plus root 23 minus root 23. So observe here children, let's now first remove the brackets here. So remove the brackets and write 3 plus root 23 minus root 23. So what you can do here, plus root 23 minus root 23. What happens? Cancel. Finally we got here 3. What is 3? Is it a rational or irrational? 3 is a rational number. So what you can write here? Therefore 3 is rational. Okay. So coming to your third question here children. 2 root 7 by 7 root 7. So what you can see here, 2 root 7 by 7 root 7. How do you write this? Can you simplify further? Yes, you can simplify. What is that? Here, root 7 will be cancelled. How can you split? 2 is a multiple, right? So this one can be cancelled. So if it is cancelled, what you are left with? 2 by 7. Now what is this 2 by 7? It is a rational number. So I can write this as rational. Okay. Next coming to your fourth one. Any rational number when it is divided by an irrational, your quotient will be irrational. So here, no need of dividing this one. Always your answer will be how much here children? It will be irrational. When your denominator is irrational, your answer will be irrational. This type of a number is a irrational number. So coming to your last one, fifth question, what you have? 2 pi. By the way, what is pi children? Pi is a irrational number. When any irrational number is multiplied by 2 times, 3 times, 4 times, whatever you multiply with any number this pi, you are going to get same irrational number only. What is the value of a pi children? Do you know? It is a never ending value. If you want, you can check in any calculators. So there is no end. Then this type of a number, what we call, it is a non-terminating, non-repeating decimal. So when that type of a decimal is multiplied with any number, same answer you are going to get. Therefore, which type of a number it is? It is irrational number. Okay. So like this, we need to classify by seeing the question. You need to classify children. Which type of a number it is, we need to understand. Okay, look here, second main children. Simplify the following expressions. I have already simplified here. Just listen carefully here. So you have your first question, 3 plus root 3 into 2 plus root 2. So what you need to remember here, children? Rational number and irrational number. Okay, if you add, you are going to get a irrational number. Here also rational plus irrational, you will get a irrational number. But now your question is, there is a product in between both of them. Okay, in between them there is a product. So you need to multiply. How do you multiply here, children? Remember carefully. First you take any one number. Okay, first set you multiply these two. Then you take second set, multiply these two. Right? So I have drawn a curve. Can you see here? 3 into 2. 3 into 2 plus, okay, 3 into root 2. How did I say plus, children? Plus into plus, plus. 3 into root 2, 3 root 2. Plus into plus, plus 2 into root 3, 2 root 3. Plus into plus, it will be plus root 3 into root 2, I have written. So now simplify this one. 3 2s are 6. 3 root 2, 2 root 3 plus. Do you remember some identity here? Root A into root B is equal to root of AB. So take a big root and write inside these two real numbers. 3 into 2, that is 6. That will be 6 plus 3 root 2 plus 2 root 3 plus root 6 is your answer. Okay, is it followed? Multiplication, children, be careful when you have these type of expressions. Go to the second one here. 3 plus root 3 into 3 minus root 3. Again, which identity you remember? Oh yes, you might be remembering two identities. What are those, children? A plus B into A minus B. A square minus B square. Or A plus root B into A minus root B is equal to A square minus B. So before one, you know before only A plus B into A minus B will be A square minus B square. The same formula also will be applicable when here little rational and irrational it was changed. Right? A plus root B into A minus root B is equal to A square minus B. Why it is B? Have you identified? Root B whole square. Square root and square and the root will be cancelled. So you are left with B here. Similarly, apply here. 3 plus root 3 into 3 minus root 3. What it will be? A square minus B square. What is A value here, children? 3. Okay, B value is also 3. According to the formula, it is 3. If you take A plus B minus B, at that time, your B value is root 3. Okay, which identity you are taking, you just remember carefully. Okay, so now is equal to A square, 3 square minus B value is also 3. 3 3s are 9. 9 minus 3 will be 6 is your answer. Coming to your third problem, children, here. Root 5 plus root 2 whole square. Again, what you are remembering here? A plus B whole square is equal to A square plus 2AB plus B square. Or you may remember this formula, that is root A plus root B whole square is equal to A plus 2 root of AB plus B. Consider here, children, compare these two. A value is 5, B value is 2. What is A value? 5. B value? 2. Now apply this formula, that is A means what? 5. 2 into root of AB means 5 into 2. Don't try to write 5 2. 5 2 becomes 52 again. See here, children, A into B it is. Okay, 5 into 2 plus B value is 2. 5 plus 2 root of 5 2s are 10 plus 2. Now finally you add these numbers. 5 plus 2 will be 7 plus 2 root of 10. Where here 2 is a multiple, 10 is a radicand and 2 is the order. If asked, you can say like that. Fourth sub question, children, here. Root 5 minus root 2, root 5 plus root 2. Again you remember which formula here? a minus b into a plus b, that will be a square minus b square. Or you may take it as root a minus root b into root a plus root b is equal to a minus b. Directly if you want, you can apply here this one. A value is how much? Compare here properly. A is 5, B is 2. A is 5, B is 2. So RHS what you have here? A minus B. RHS means what again? Left hand side, right hand side. Okay. So given left hand side, you need to write the RHS. So root 5 minus root 5 minus root 2 into root 5 plus root 2. It will be how much, children? 5 minus 2. That will be 3. Okay. I hope this main is clear for you. You can take many examples and you can solve these type of questions. See the third problem here, children. What is your third problem? Recall pi is defined as the ratio of the circumference. See here, children. Pi is defined as the ratio of circumference, say C, of a circle. So look here, children. So this is the circumference of a circle. Do you know? Outer ring, we call it as a circumference of a circle. To its diameter. Where is the diameter here? This is the center. This is the diameter. So observe here carefully what they are saying. Pi is the ratio of circumference of a circle to its diameter given. So what they are saying here, this seems to be a contradict that fact that pi is irrational. How will you resolve this contradiction? Why? What is there here contradiction? There is no contradiction at all, because see here, anything it might be irrational. Either it may be circumference of a circle or diameter. Anything might be irrational. So look here, children, any rational or irrational number when you measure with anything with the point differences you are going to get. So in these two, anything might be irrational. If you divide any rational with irrational, what you are going to get? You are going to get an irrational answer. Therefore, there is no contradiction here. Anything might be irrational. Therefore, pi is irrational. There is no contradiction here. Okay. So let's move to the fourth question here. Represent root of 9.3 on number line. So do you remember your last class, children? How do we have done the number line here? Same pattern. So once again, let's start with the freehand drawing here. First, what we have done? Take a line. Okay, take a number line. Okay. So 9.3. How do you mark here, children? So from 0, I will start. 1, 2, 3, 4, 5. Take a scale, proper scale you need to take here. 9, 10, 11. Okay. So now what you need to mark? From 0. So let me take here any letter A. Okay. How much here? Root of 9.3, no? So count from here, measure here. 9.3. Mark a point B. So what's your first step? Draw a number line, right? Mark 9.3 from 0 to 9.3. Mark A, B. So now what's your next step? Do you remember? Take 1 centimeter extra. How much you need to take? A unit length extra. So 9.3 means mark here 10.3. You mark a point C. What is that point there? 10.3. Now with A and C as a center. With A and C as centers, more than half above one arc, below one arc. And from C point, cut the arc. Why are we doing here? In order to do the midpoint of a line AC. So now approximately look here, children. Your point will be getting somewhere here. Okay, 10.3. 10.3 half, it will be how much? 5.12, like this you are going to get. So somewhere, let's guess here. So when you draw a bisector, anyhow you are joining like this. You don't adjust the marks here. Okay, this is a rough line I am drawing. So from A, more than half, draw an arc above and below. From C, draw an arc above, below, draw the perpendicular bisector. So what does it do here? It shows you midpoint. Now, afterwards, if you want, you can erase this part. So with this as a center, do the semicircle. With that as a center, do the semicircle. Now what you need to do here, children? So this is 11. Now little I'll extend in order to plot root of 9.3 on number line. Okay. So here, what did I do now? This is a bisector and this is the center. I have drawn a semicircle. Now, from the point B, draw perpendicular. So like this, draw the perpendicular line from B. So now here, children, from this as a point, measure and extend the semicircle from here. This as a point, extend. See here, this is your root 9.3 value. So once again, I repeat here, children, it was explained in part 5 very clearly, right? So observe here carefully what we have done. So observe this part very careful. If you want to check, you can go with the formulas what we have done. Root x, okay, x plus 1 by 2 or x minus of x plus 1 by 2. This all we have done. Do you remember? So those formulas, if you want, you can apply here. So once again, I am showing this number line with a free hand, but you have to do with the scale and skiver properly. So first step, what I have done here, draw a number line with a unit, each one unit you draw. So at least up to 15 points you draw on a number line. So now from 0, no negative numbers not needed here. From 0, what you need to do? 9.3 centimeters, mark point A and B. From 9.3, take one more unit extra, that is 1 centimeter extra. 10.3, mark C point. Okay, so if you want, you can write your letter B here and C here. No problem. So, with A as center, draw an arc above, below. With the C as center, cut the arc. Why are we doing? In order to find the perpendicular bisector or this line midpoint you may feel. So after getting this, what you have done? With this as a center, draw the semicircle. Okay, after doing your semicircle, go back to the point where you have drawn 9.3, one point you have marked B, Noma. There you do the perpendicular. Okay, what do you mean here? So what you are doing here? Perpendicular, 90 degree. So 90 degree line where it touches. If you want, you can take with protractor also. You can do 90 here. So this line where it touches the semicircle. Okay. Measure with skiver from here to here and draw the, extend the semicircular arc here. So this arc where it touches on number line, that is the value of root of 9.3. Okay, children, I hope you have followed. Do this on your rough notes carefully, right? 1 or 2 times you can practice. So look here, last main of this exercise. Rationalize the denominator. This is the basic we did not discuss in our last class. So observe here, children, what we need to do here. Rationalize. What is this rationalize here? The denominator. So look here, denominator. Now what is this number here? It is rational and it is irrational. So when you rationalize, why we need to rationalize? In order to convert the denominator into a rational number. Numerator may be anything, but your denominator must be rational. So observe here carefully. How do we do this? We need to rationalize by taking the conjugate of the denominator. What is a conjugate? How to understand this conjugate here, children? Suppose if I ask you root p, what you multiply to get a rational number here, children? Root p into root p. What happens? Root of p whole square, square root cancel, p is your answer. P is a rational, right? So if you have a single surd, the same value you need to multiply numerator and denominator. When you are rationalizing, you need to multiply for numerator and also denominator. Suppose if you have, this is a monomial surd, children. This is a binomial surd. What do you mean by binomial? 2. Monomial single surd will be there. When you have a binomial surds, what you need to do? How do you remove this root here? Here you can see it is in the form of root a minus root b. With what you multiply to get a minus b? Yes, root a minus root b is multiplied with root a plus root b. You get a minus b. As you know, this identities before main we have done, no children, same manner. So observe here, suppose if I take any other number, suppose let me take here root 3 plus root 2, 1 by you have. So I need to rationalize this. Rationalize means what we need to do? We need to multiply for the numerator and denominator with the conjugate form. Conjugate word. What is conjugate here? Reverse sign. If this is minus, you write here plus. So conjugate of root 3 plus root 2 is what? Root 3 minus root 2. When you are rationalizing, you are multiplying numerator and denominator with this binomial surd. Root a plus root b into root a minus root b. What happens here, children? A minus b. That is 3 minus 1. Root 3 minus root 2 by 1, or simply you can write it as root 3 minus root 2. Makes denominator a rational. Okay, this main we need to do in this method. So quickly let's start main here. Yeah, first question, 1 by root 7. So here denominator, observe children, it is a monomial surd. So only root 7 you have means what you need to do? Root 7 only you need to multiply numerator and denominator. One more thing you remember here. Suppose if you have root p minus q, I will say. What is the conjugate of this? Don't say root of p plus q, don't say. Why? This full set is in a single root. When your root splits, your sign changes. When your root is not splitting, your sign won't be changed. So what is this type of question? How do you do rationalizing? So same thing you need to multiply. Okay, root of p minus q I am saying. Suppose if you have root p minus root q, then your sign changes. What is the conjugate of this? Root p plus root q. You need to multiply numerator and denominator. So observe here, understand carefully. Let's start here. First main. Let's start here. Fifth main, first problem, children. What is that? 1 by root 7. What is the conjugate of root 7? Root 7 itself. So what we need to do? Multiply. You can write here. Multiply numerator and denominator by root 7. Okay. So multiply here. What you are going to get, children? That will be 1 into root 7, root 7. Root 7 into root 7 whole square. Square root cancel. That will be root 7 by 7 is your answer. So now your denominator is rational or not? That is only the thing we need to do here. Rationalize the denominator. So now observe your second sub question here. What is this? Multiply. So here, multiply numerator and denominator by the conjugate. What is the conjugate here? Root 7. Multiply numerator and denominator by root 7 plus root 6. Okay, so now let's start multiplying here, children. 1 by root 7 minus 6 into root 7 plus root 6 by root 7 plus root 6. So numerators multiply here. That is 1 into root 7 plus 6 will be root 7 plus root 6 whole divided by root 7 minus root 6 into root 7 plus root 6. So do you remember here one identity here, children? What is that? Root a minus root b into root a plus root b. What it is? It will be a minus b. See here, whatever identity you observe here or you use here, you have to write root a plus root b into root a minus root b is equal to a minus b. I am using this identity, right? So now, according to that, what I can say? Root 7 plus root 6 by 7 minus 6. Or directly you can write it as root 7 plus root 6 by 1. This is your answer. We have rationalized the denominator. Look here, third problem. 1 by root 5 plus root 2. So you need to rationalize the denominator. What is the conjugate of the denominator, children, here? Root 5 plus root 2 there. So it is a binomial surd. So what is its conjugate? Plus there in your denominator. You need to multiply numerator and also denominator. Numerator and denominator by root 5 minus root 2. So observe here, children, here plus there you need to multiply with minus there. So now take the question, 1 by root 5 plus root 2 into root 5 minus root 2 by root 5 minus root 2. So now look here, children, 1 into anything else, that value root 5 minus root 2 by root 5 plus root 2 into root 5 minus root 2. So now how do you write here? Root 5 minus root 2 by, you can remember here what is that? Root a plus root b is into root a minus root b. So once again, denominator how it is, children? Root a plus root b into root a minus root b. Which form it is? A minus b. Right? Directly you can write here 5 minus 2. That will be root 5 minus root 2 by 3. You can write it as, since root a plus root b into root a minus root b is equal to a minus b. So look here, this is your answer. So what's your last sub question here? That is 1 by root 7 minus 2. Root 7 minus 2 there. What is its conjugate? Root 7 plus 2, right? So now multiply numerator and denominator by what, children? Root 7 plus 2. So now let's start here. 1 by root 7 minus 2 into root 7 plus 2 by root 7 plus 2. Numerators you multiply, denominators you need to multiply. That will be root 7 plus 2 whole divided by root 7 minus 2 into root 7 plus 2. This is which form? Again you can remember something. Root a minus b into root a plus b will be, what is this formula? A minus b square. Or you can remember a minus b into a plus b formula also you can remember. So if you take that formula, root 7 plus 2 by a square minus b square, that will be root 7 plus 2 by square root cancels, children, here. 7 minus 4, that will be root 7 plus 2 by 3. So this is your answer. So which formula you have applied here? So which formula you have applied here, children? It is a minus b into a plus b, that is a square minus b square. So when you apply, you are going to get your answer root 7 plus 2 by 3. So with this, we have completed this main and also exercise 1.5 children. So in our next session, we are going to meet with your last exercise in your number system. Until that, keep on practicing. Thank you all.